So today we are going to discuss some problems on transient phenomena. Okay. So first problem we are going to discuss is this particular problem. The question is a series RC circuit containing R is equal to 10 mega ohm. Okay, resistance connected is 10 mega ohm and C is equal to 10 microfarad is connected to a DC voltage source of 10 volt. So this is the circuit, and what we have to determine time constant of the circuit. Number 2, voltage across the capacitor at 100 second and current through the circuit at 200 second after switching the source on. So 3 important parameters you have to determine. So consider this problem, which is a series RC circuit containing resistance equal to 10 mega ohm and capacitor is 10 microfarad, that is the magnitude of capacitance, and that series combination is connected to a DC voltage source of 10 volt. A 10 volt battery is connected. So first you write the given quantities. Okay, what are the given quantities here? Resistance is given. So resistance is 10 mega ohm, that is given, that is equal to 10 into 10 to the power 6 ohm. Capacitance C is given, that is 10 microfarad, that is 10 into 10 to the power minus 6 farad. Okay, micro means 10 to the power minus 6. Mega means 10 to the power plus 6. And voltage of the battery that is connected is given, that is 10 volt. Okay, these 3 parameters are given. So one by one we'll try to find the given problem. First you have to find the time constant of the circuit. What is the expression for time constant? Anyone? In series RC circuit, what is the time constant?
T is equal to R into C.
T is equal to R into C. Good. So first you calculate time constant. So therefore, time constant of the circuit is T is equal to R into C. Okay. So what is the value of R? It is given, it is 10 mega ohm. That is 10 into 10 to the power 6 ohm. Okay. And the capacitance C is 10 microfarad. That is 10 into 10 to the power minus 6 farad. Micro means 10 to the power minus 6. Okay. So substitute and calculate. Okay. Can you substitute and calculate the time constant? So R is 10 into 10 to the power 6 into C is 10 to the power 10 into 10 to the power minus 6. What is the final result?
100 seconds.
It is 100 seconds. Very good. Because 10 to the power plus 6 into 10 to the power minus 6, that too gets cancelled. They cancel actually. So simply the answer will be 10 into 10. 10 into 10 is 100 second. Okay. So therefore, time constant of the circuit is 100 seconds. Okay. That is the answer for the first question here. Okay. Next, second question. What is the voltage across capacitor at 100 second? Remember, we have obtained the time constant is equal to 100 second. Time constant of the circuit is 100 second. Now we have to find out what is the voltage across the capacitor at that time, which is equal to the time constant. Okay. So what will happen to the voltage at the time T is equal to RC? Because 100 second is nothing but T equal to RC. ಈ 100 second ಅಲ್ಲಿ voltage ಎಷ್ಟು increase ಆಗ್ತದೆ ಅನ್ನೋದನ್ನ find out ಮಾಡಬೇಕು. That is the second question. Let us see. So after 100 second, T is equal to 100 seconds. We have to find the voltage. Since the time constant of the circuit is 100 seconds, just you have calculated. Therefore, at that time, the voltage across the capacitor becomes 0.63 times the voltage of battery after 100 seconds. Okay, we know that at a T is equal to time constant, the voltage of the capacitor becomes equal to 0.63 times of maximum voltage. What is the maximum voltage? That is voltage of the battery, that is 10 volt in this question. Okay, so therefore what is the voltage? It is 0.63 times of the maximum voltage. Therefore after T is equal to 100 second, VC, voltage across the capacitor, is equal to 0.63 times of the V naught. What is V naught? It is 10 volt. So what is the voltage? Can you calculate?
6.3 volts.
That is definitely 6.3 volt. Okay, that is the voltage across the capacitor at t is equal to 100 seconds. You recall the definition of time constant. How I have obtained this particular equation? Because at t is equal to 100 seconds, that means t is equal to RC. That's why at that particular time constant, the voltage becomes equal to 0.63 times of maximum voltage. What is the maximum voltage? Maximum voltage is battery voltage. They have given battery voltage equal to 10 volt here. Okay, 10 volt anta kottidare. Battery voltage is 10 volt. That's why 0.63 times of 10 volt you have to obtain. Okay, so this is how you can obtain this particular term 0.63. So 6.3 volt is the voltage across the capacitor at t is equal to 100 seconds. Next, what is the third question? You look here. Third question is you have to find the current through circuit at 200 seconds after switching the source on. Okay, at t is equal to 200 seconds, what is the current you have to find out? Remember, this is the charging case because battery is connected here. Battery connect ಮಾಡಿದ್ರೆ ಅಂತ ಅರ್ಥ ಏನು? Capacitor is charging. So charging ಆಗಬೇಕಾದ್ರೆ ನೀವು current ಅನ್ನು find out ಮಾಡಬೇಕು. Third question. Let us go to that question. So after t is equal to 200 seconds, we have to find the current through the circuit. That is given by I is equal to I naught into e to the power minus t by RC. Okay, have you got this equation? Idu discuss ಮಾಡಿದನೆ. ಇದು ಲಿಸ್ಟ್ ಅಲ್ಲಿ ಬರ್ಕೊಂಡಿದ್ದೀರಾ? I have told you to write the list of equations. Okay, have you made that? A list ಮಾಡ್ಕೊಂಡಿದ್ದೀರಿ? Have you made that? Okay, no problem. So this is the expression. Okay, so if you have not done, you try to make the list of expressions. Okay, list of formula. ಅದನ್ನು ಮಾಡ್ಕೊಳ್ರಿ. Now we have to find this current I. What is I naught? I naught we have to find, that is the maximum current. T is given, that is 200 seconds. R is given, C is given. R into C already you have calculated. What is the value of R into C? R into C is 100 seconds. That is already calculated. Now we have to calculate this I naught. What is I naught? That is the maximum current. So maximum current is given by V divided by R. Okay, I naught is given by V naught by R. What is V naught? V naught is the voltage of the battery. Okay, now you calculate where I naught is the peak current or maximum current. What is the expression for I naught? That is V by R or V naught by R. What is V naught? V naught is the voltage of the battery. Therefore, you calculate this I naught. So what is the voltage of the battery? That's 10 volt. What is the resistance value? It is 10 mega ohm. So therefore, I naught first you calculate. Therefore, I naught is equal to 10. That is the 10 volt. That is battery voltage divided by 10 mega ohm. That is 10 into 10 to the power 6. So 10 into 10 gets cancelled. It will become 1. 10 to the power 6. If you take it to the numerator, it will become 10 to the power minus 6. So you get the answer 1 microampere. That is the maximum current. So I naught is maximum current, which is equal to 1 microampere. You substitute here. T ಗೊತ್ತಿದೆ, RC ಗೊತ್ತಿದೆ, I naught ಈಗ calculate ಮಾಡಿದ್ವಿ. You substitute and finally calculate the value of I at t is equal to 200 seconds. Okay, next, at t equal to 200 seconds, you substitute the values here. So I naught is 1 into 10 to the power minus 6 ampere. Micro means 10 to the power minus 6. 1 into 10 to the power minus 6 ampere into e to the power t. T is 200 seconds. What is the value of RC? RC is 100 seconds. Already we have calculated. That is the time constant. Okay. So simplify it further. So it is 1 into 10 to the power minus 6 into e to the power minus 2. It becomes, that is minus 200 by 100 is minus 2. E to the power minus 2. Can you calculate this e to the power minus 2? So have you got e to the power minus 2 is equal to 0.135? Anyone? Have you got the same answer? 0.135, that is e to the power minus 2. So in the calculator, you can find e to the power minus 2 into 1, that is 0.135. Definitely you are going to get that answer. So 10 to the power minus 6 means it is micro. Therefore, the answer will be 0.135 microampere. Okay, microampere is the answer for this particular question. Okay, just to recall, so 3 questions they have asked. They have given the RC circuit containing resistance, capacitor, and a series connection with a battery of voltage 10 volt. Okay. So first question they have asked is you have to find the time constant of the circuit. Simply by taking T is equal to R into C, you can find the time constant. Then they have asked the voltage across the capacitor at 100 seconds, and you come to know that the time constant of the circuit is 100 seconds. Therefore, at that particular time, the voltage will be equal to 0.63 times of battery voltage. That's why by using that technique, we can calculate that T is equal to 100 seconds, voltage will be 0.63 times of 10 volt, that is 6.3 volt. Then third question, you have to find the current at T is equal to 200 seconds, and expression for current is I is equal to I naught into e to the power minus T by RC. I naught is nothing but voltage of the battery divided by resistance, that is the maximum current. Calculate I naught, it comes out to be 1 microampere. You substitute here in this expression, T is 200 seconds, RC is 100 seconds. You will get 1 into 10 to the power 6 into e to the power minus 2, and if you calculate, that will be 0.135 microampere. That is the answer for this particular question. Okay, so just I will show you how this e to the power minus 2 comes out to be 0.135. Just I will show you. Okay, just I will show that in the calculator. So e to the power minus 2 you have to take. This is e to the power, open the bracket, minus 2, close the bracket. Okay, and that is how we can, okay, sorry. So e to the power minus 2, okay, I'm not showing the answer. In just a minute, I'll show you. So 1 by e square I can do. Okay, so basically 1 by e square, 1 e to the power minus 2 means 1 by e square, 1 divided by e squared. Okay, so close the bracket. So that will be equal to 0.135 something. Okay, 0.135. It is showing long answer. So you can take 0.135 is the answer for that. Okay, so that is how we can take the particular answer. Okay, so that comes out to be 0.135. E to the power minus 2 means it is 1 by e square. It is 1 by e square, just like that. Okay, then we'll go to the next problem. So second problem we'll take. This problem is also on the series RC circuit only. So read the question carefully. A series RC circuit containing a resistance of 1 mega ohm is connected to a battery of potential 5 volt. Okay, it says that 1 mega ohm resistance is connected to a battery with 5 volt potential, and it is a series RC circuit. They have not given the value of the capacitance. Okay, so then now find out what. Read in the next sentence, calculate the capacitance of the capacitor if time constant of the circuit is 100 seconds. They have given time constant of the circuit is 100 seconds. Using that, you have to calculate what is the capacitance of the capacitor. C value you have to calculate. Next sentence, also calculate the charge on capacitor and voltage across capacitor at t is equal to 50 seconds during charging of the capacitor. Okay, also calculate the charge on capacitor and voltage across the capacitor at t is equal to 50 seconds during the charging of the capacitor. New charge find out ಮಾಡಬೇಕು, voltage ಕೂಡ find out ಮಾಡಬೇಕು at t is equal to 50 seconds. Okay, next, what are the given quantities? You write slowly. So given quantities are resistance is given, resistance is 1 mega ohm, that is given. Voltage of the battery V0 is given, that is 5 volt. Okay, then time constant of the circuits tau is given, that is 100 seconds. So one by one you calculate. First you have to calculate what is the capacitance of the capacitor. How to calculate that? R is known, time constant of the circuit is known. Therefore, is it possible to calculate the capacitance? Anyone?
Yes, sir.
Using the which formula you have to use?
T by R.
T by R. Okay, definitely that is right. So we have the time constant of the circuit, tau is equal to RC, T is equal to RC. Therefore, C will be equal to T by R. Therefore, C will be equal to T by R. What is T? It is 100 seconds. What is R? R is 1 mega ohm. Mega means 10 to the power 6. Then calculate, it will be 100 into 10 to the power minus 6. Because 1 into 10 to the power 6 and numerator 10 to the power minus 6 ಆಗ್ತದೆ. Okay. So 1 by 10 to the power 6 means it is 10 to the power minus 6. Okay. So that will be in farad. Therefore, C will be 100 microfarad. 10 to the power minus 6 means micro. So capacitance of the capacitor is found to be 100 microfarad. Okay, that is first question. Next, you have to calculate the charge on capacitor and voltage across the capacitor at t is equal to 50 seconds. At t is equal to 50 seconds, what is the charge? What is the voltage? You have to find out. Let us do that. What is the expression for charge? Charge is given by Q is equal to Q0 into 1 minus e to the power minus t by RC. So RC, we know RC is the time constant. So time constant is given as 100 seconds. T at 50 seconds you have to find. What is the value of Q0? Q0 is given by V0 by C. Okay. So charge is V by C. Okay. Sorry, V into C. V0 into C. Q0 is V0 into C. You calculate Q0, then you calculate the value of QCP. Where Q0 is the maximum charge stored in the capacitor where it is fully charged to battery potential. And this Q0 is equal to V into C. What is the value of V? Battery voltage, it is 5 volt. What is the capacitance value? Just you have calculated, that is 100 microfarad. Okay. Next, so substitute the value of V and C. V is 5 volt, C is 100 into 10 to the power minus 6 farad, 100 microfarad. So this will be 500 microcoulomb. So charge on the capacitor Q0, that is the maximum charge, which is equal to 500 microcoulomb. Okay, 500 into 10 to the power minus 6. Now you have to find Q value. By knowing Q0, which is equal to 500 microcoulomb, T is 50 seconds, then RC, they have given it is equal to 100 seconds. So therefore, at T is equal to 50 seconds, Q is equal to, that is 500 into 10 to the power minus 6, that is Q0 into 1 minus e to the power minus T is 50 seconds divided by RC is 100 seconds. Okay. So therefore, that will be equal to 500 into 10 to the power minus 6 into 1 minus e to the power minus 0.5, because 50 by 100 is 0.5. It is half. It is 1 by 2 iddange. 1 by 2 andre half. Okay. Can you calculate this? So if you calculate this particular value, 1 minus e to the power minus 0.5, is calculate ಮಾಡಿದ್ರೆ ನಿಮಗೆ you will get 0.393. 0.393 you will get into 500 into 10 to the power minus 6. Okay. And if you multiply this, what will be the answer? You multiply 500 into 0.393. What will be the answer?
196.5.
It will be 196.5 microcoulomb. 10 to the power minus 6 means it is microcoulomb. Okay, that is how we can calculate the charge on the capacitor. Similarly, you find the voltage across the capacitor at t is equal to 50 seconds. What is the formula? So this is the formula. Is it right? Voltage across the capacitor is equal to V naught into 1 minus e to the power minus t by RC, where V naught is the maximum voltage of the battery. So Vc is the voltage across the capacitor at t is equal to 50 seconds. You substitute. What is the battery voltage? It is 5 volt into 1 minus e to the power minus 50 by 100. Just you have calculated e to the power minus 50 by 100 is e to the power minus 0.5, that is equal to 0.393. You multiply it by 5. What will be the answer? It will be 1.
1.965.
1.965 is the answer for that. How much of volts? Okay, so this is the voltage across the capacitor at a t is equal to 50 seconds. Okay, so that is the answer for this voltage across the capacitor. So this is how you can solve the problem by knowing the particular expressions. You should list the different expressions corresponding to that. So next problem. This is the problem on series RL circuit. Okay, third problem is on series RL circuit. Read the question. A series RL circuit with inductance 50 Henry. Okay, inductance 50 Henry and resistance of 10 ohm carries maximum current of 5 milliampere. A series RL circuit with inductance 50 Henry and resistance of 100 ohm carries maximum current of 5 milliampere. How long it takes to increase the current to half of its maximum when a battery of 1 volt is connected to across RL circuit? Also find current at t is equal to 2 seconds. Okay, this is the simple problem. They have given the series RL circuit with inductance 50 Henry. The inductance of the inductor is 50 Henry. So Henry is the unit of inductance. And resistance of 10 ohm. 10 ohm resistance is connected. It is very small resistance. Carries maximum current of 5 milliampere. The circuit can carry the maximum current I0 is equal to 5 milliampere. How long it takes to increase the current to half of its maximum when the battery of 1 volt is connected across RL circuit? So now growth of current is going to be observed. So it is battery is connected in the circuit, that's why current is going to grow. During the growth of current, what is the time at which current becomes half of its maximum? What is the maximum current? It is 5 milliampere. 2.5 milliampere ಆಗಲಿಕ್ಕೆ ಎಷ್ಟು ಟೈಮ್ ಬೇಕು ಅನ್ನೋದನ್ನು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ಓಕೆ, ವಾಟ್ ಇಸ್ ದ ಟೈಮ್ ರಿಕ್ವೈರ್ಡ್ ಟು increase the current to 2.5 milliampere? That is half of the maximum current when battery is voltage connected is 1 volt. And also find current at 2 seconds. adu kuda find out madoಣ. 2 questions ante. Let us write the given quantities. What are the given quantities? Resistance R is given, that is 10 ohm. L, inductance of the inductor, is given, that is 50 Henry. Maximum current I naught, which is equal to 5 milliampere, that is given. Battery voltage V is equal to 1 volt, that is given. You have to find what is the time at which the current becomes 2.5 milliampere, half of the maximum. So expression for instantaneous current is given by I is equal to I naught into 1 minus e to the power minus R by L into T. That is the expression for current during the growth of current in RL circuit. I have discussed it already. Okay, where I naught is the maximum current. That is directly given. Now you have to find this time t when this I is equal to I naught by 2. I equal to I naught by 2 ಆಗ್ಲಿಕ್ಕೆ ಎಷ್ಟು ಟೈಮ್ ಬೇಕು ಅನ್ನೋದನ್ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. Resistance R is given, L is given, I naught is given. You have to find time t at I is equal to I naught by 2. That is the question. Okay, next is simple mathematical steps. So when I is, the current becomes half of its maximum, then you can put I is equal to I naught by 2. So maximum current in a half ಆಗಬೇಕು, I naught by 2 equal to I naught into 1 minus e to the power minus R by L into T. Okay. So now I naught gets cancelled. ಇದು ಎರಡು cancel ಆಗ್ತದೆ. You will get 1 minus e to the power minus R by L into T is equal to 0.5. Okay. Have you got this line? So 1 minus e to the power minus R by L into T is equal to 0.5, half of the maximum. I naught gets cancelled. It becomes half. That is 0.5. Or you can write e to the power minus R by L into T. This term is equal to 1 minus 0.5. 1 minus 0.5 is 0.5. So we have got e to the power minus R by L into T is equal to 0.5. Now take natural logarithm on both sides. You take ln on both sides. Log of e to the power minus R by L into T equal to log to the base e of 0.5. So that will give you minus R by L into T. Log of e to the power minus R by L into T is R by L into T. That is equal to ln of 0.5. Okay. So you have to use the logarithmic equation. Log to the weights e to the power x is nothing but x. Okay. Next you solve. You put R and L, you find T value. So next you solve this equation, you have to find the value of T. Okay. Therefore, you will get a T is equal to minus L by R into ln of 0.5. Okay. Put the value of L. What is the value of L? It is 50 Henry. What is the value of R? It is 10 ohm. So put the values. 50 divided by 10 into ln of 0.5. So ln of 0.5 is minus 0.69. You can use the calculator and you can find ln of 0.5. How much it is? Can you calculate? Anyone?
Minus 0.693.
Minus 0.69. So L is 50 Henry, R is 10 ohm. So 50 divided by 10 is 5. So you'll get 5 into 0.69 minus to minus, it becomes plus. If you multiply that, you will get 0.45 seconds. Sorry, 3.45 seconds. So at 3.45 seconds, what will happen? The current becomes equal to half of the maximum ಆಗಿರ್ತದೆ. ಅಂದ್ರೆ 2.5 milliampere current grow ಆಗ್ಲಿಕ್ಕೆ it takes only 3.45 seconds. After 3.45 seconds, the current becomes equal to 2.5 milliamps. Okay. So next question, ಇದರಲ್ಲೇ ಕೇಳಿದರೆ also find current at a t is equal to 2 seconds. You have to find the current at a t is equal to 2 seconds. So next use the formula. So it takes 3.45 seconds to observe the current equal to half of its magnitude. That is the question answer. Then also current at t is equal to 2 seconds is given by this expression. You have to find what is the current I at t is equal to 2 seconds. That's all. I naught is given. I naught is 5 milliampere. So I naught you substitute. I naught is equal to 5 into 10 to the power minus 3. Milli means 10 to the power minus 3 into 1 minus e to the power minus 10 into 2. 10 is resistance 10 ohm. 2 is 2 second t time t divided by L is 50 Henry. So 10 into 2 is 20. 20 by 50 is 2 by 5. What is the value you can calculate? So it is minus 2 by 5. So e to the power minus 2 by 5 is observed to be 0.67. Okay. If we calculate e to the power minus 2 by 5 is observed to be 0.67. Okay. So 1 minus 0.67 is 0.33 into 5 into 10 to the power minus 3. So multiply 5 into 10 to the power, into 0.33. What is the answer? 5 into 0.33.
1.65.
So that will be 1.65 milliamps. Very good. Okay. So this is the current at t is equal to 2 seconds. Okay. T is equal to 2 seconds. Yes, current bರ್ತದೆ 1.65 milliamps. Okay. So these 3 problems are enough today. So we'll take some more problems in the next class.